make sure you go back and read through your notes. Okay, very important. And also, if you have a problem doing, if you can't do a question, if you're having issues with a question, go back in your textbook, read the textbook. The textbook is another resource for you. So you should know how to look through your textbook, read your textbook to help you. Yeah, you guys are gonna get a textbook. Okay, so while you guys are copying this, I'm gonna just go run and get some textbook. Okay, so we're going to talk about slope of a tangent. First of all, what's slope? And you guys at home, feel free to shout out some answers, it's fine. Slope, what is slope? Who can talk to me about slope? Nobody?
Time?
Yeah. Rise over run, is that what you said?
Yes.
Good. Slope is rise over run. To find slope, we do y2 minus y1 over x2 minus x1. It's the change in your y's over the change in your x's. It is also referred to as a rate of change. What's the difference between a slope and a rate of change? Who knows? There's a difference. What's the difference between slope and rate of change? So rate of change has units. So when you're asked for a rate of change, they want the units involved. So for example, kilometers per hour, meters per second, whatever the case may be. Okay? That's the difference. But a slope is still the rate at which your graph is changing. So when we talk about slope, we're talking about rate of change. We're talking about the steepness at a certain part of your graph. When we talk about linear functions, we know that the slope is always the same. But if we start talking about curves, that is no longer the case. The slope changes. So when I look at this curve that I have here, I notice that my steepness changes. Okay, so if I'm looking at the point PQ, and then I compare that one, and it's called a secant. The reason that this is called a secant is because it's passing through 2 points on my curve. Okay, so that's a secant. So when I look at this secant, PQ, and I compare it to PQ1, I notice that the slopes are different. Which one is steeper? Yes, Nigel? Yeah, PQ1 is steeper. And then I have PQ2. And now which one's the steeper out of the 3? Yeah? PQ2. And then I have PQ3. And that's getting even steeper. So I notice that these secants, the slope of these secants is getting steeper and steeper and steeper. The closer I get to P. So the closer Q is getting to P, the steeper the line is getting. Now when you analyze this curve, you should notice that here, if I look at rise over run here, there's my rise over run. And I compare it to this. We see that this curve is getting steeper. You see that the rise is bigger than the run, and there's a much bigger difference with PQ3 than there was with PQ2. So this curve, as we follow this curve towards P, it's getting steeper. Okay? So it's flatter here than it is here. Yeah? Good. Excellent. So we know that the slope is equal to yq minus yp over xq minus xp. So that's just talking about taking the coordinates from P and Q. right? So P will have coordinates x, y, and so will Q, x, y. As Q moves closer to P, the slope of the secant PQ gets closer to the slope of the tangent at P. So what's a tangent? The tangent is that black dashed line. It is touching my graph at one point. That's why we call it a tangent. We only care about the slope at that one point P. So what's happening is, as this point Q gets closer to P, we notice that the slope is getting closer to that tangent. Right? Do they see that? Now, in MHF, you guys didn't learn about limits. Without learning about limits, you guys cannot find the slope of a tangent exactly. So what you guys did was, you found the slope of a secant, which is just y2 minus y1 over x2 minus x1, but you chose points that were really close together. So you approximated the slope of the tangent by choosing a point that was so close to it. In this course, we're going to find it exactly by taking what's called a limit. Okay? So in calculus, we define the slope of the tangent at P as the limit of the slope of the secant PQ as Q approaches or gets closer to, that's what approaches means, to P. So what is a limit? A limit is a value that a function approaches. So when you're talking about a limit, you don't care about what it actually equals. You might have a hole there, but what is your function approaching? What is it approaching? What is the intended height of the function? Okay. Tell me when you guys are ready for me to go to the next slide. May I go to the next slide? Is everyone good? Yeah, everyone at home, are you guys good? Okay.
Yep.
Protest if you need me to go back. Okay, example 1. Find the slope of the secant PQ for the parabola y equals x squared minus 1. So we have this parabola, and we want to know the slope of the secant between P and Q. I don't know P and Q. All I know is that the x value of P is 2. If the x value of P is 2, then I know that Q has to be bigger than 2. You guys agree with me? Because Q is to the right. You guys see that? This is to the right, so it has to be bigger than 2. So there is some difference here between P and Q, the x value. We're going to call that difference h. So I'm going to say that P is 2, and then Q is 2 plus h. That's the difference between them. I'm going to give you 3. 2 comma 3. If I know, actually, I don't even have to give you 3. You could have solved with 3, yes? Here I have P at 2. So all I have to do is sub in 2 here. And I see that y is equal to 3. So y is equal to 3. If I want to know what it equals at 2 plus h, I just have to sub in 2 plus h, yes? Okay, good. So we know slope is equal to y2 minus y1, oops, over x2 minus y. Okay, so what's my y2? Do I know my y2? So do I know my y2? It's blank. That's my y2. What can I write down for y2? How do I find y2? So we found this value of 3 by subbing in 2. how am I going to find my y value of Q? Anyone? Anyone at home? So whenever you want to know a y value, what do? We have a function, we have an equation, we know this curve, we have it. So if I want to know what the coordinating y value is, I just sub in that. So that's what I'm going to do here. So I'm going to sub in the x value. Oops. So my x value is 2 plus h. So that's what I need to sub in. So it's 2 plus h all squared minus 1. That's my y2. Minus 3, we found that out, nice and easy. All over 2 plus h, that's my x2, minus 2. Is everyone following me so far?
Yes.
Good. So this is just this other highlighter. Okay? This is subbing in that x value. We don't like to do our work separately and then sub it in. That's why I didn't solve for that y2 separately. I put it right into my equation. Okay, so we don't want to solve that on the side and then sub it in. We want to do it all together as one. Okay? All right. Next, what should I do if I want to simplify this? Now it's just simplifying. We've already subbed into the formula. What do I need to do to simplify this? What do I need to do to simplify this?
Expand.
Yeah, expand. Beautiful. Now, guys, be careful here because I know you guys know this, but somehow when you guys are stressed and you're writing the test, this is one of the biggest mistakes we see. That's the biggest mistake. And I know you guys know it. I know you know that this is not correct. But somehow when you're stressed, it comes up. So be very mindful. Okay? Be careful. When you have a binomial that is squared, write it out twice. Okay? Write it out twice. What happens in my denominator? What am I left with?
There's still a -1 on the top.
Oh, sorry. Thank you. Thank you, thank you. Let's not forget our -1. Oops. So there's my -1. Let's close it up. -3. There we go. And now, in my denominator, what am I left with? 2 plus h minus 2. Well, we've already said the difference between these 2 points is h. Okay, expanding. What does this equal? Who can expand this for me? Who can expand this for me? Nice and easy. Come on, guys. It's just a foil. Who can do it for me? And no one looks at me. Anyone at home want to try? No one wants to do it. Okay, 2 times 2 is 4. And then I have 2 times h, which is 2h, plus 2 times h, which is 2h. You add the two together, it's 4h, plus h squared, -1, -3, all over h. When I clean this up, what am I left with? H squared. And then I've got 4 minus 1 minus 3. What is that? It's 0. So I'm left with 4h. Am I fully simplified? Am I fully simplified here? No. What can I do? Sure can. These cancel. That is my slope. That is the slope between those two points. H plus 2. So what does that mean? Whatever that difference is between those 2 points, whatever that x value difference is between those 2 points, add 4 to it. All right, that's what H is. It's that little difference between the two x values. As Q moves closer to P, H moves closer to 0. Let's talk about that. As Q Q gets closer to P. So let's make it closer. Let's put it here. What's happened to my H now? H has gotten, look, H was this. That was H, right here. Now, H is just this. H has gotten smaller. And the closer I get, look, that H just keeps getting smaller. Do you guys see that? Okay, so we say that H, as H approaches 0, right? H is approaching 0. Okay. So as Q moves closer to P, H moves closer to 0. We say that H approaches 0, and it's shown with an arrow. When H approaches 0, H arrow to the right, 0. H approaches 0. The slope of the tangent at P is the limit of the slope of the secant PQ as H approaches 0. Okay, so slope of tangent at P equals. So you take the slope of the secant. What was the slope of the secant? We found it. What was the slope of the secant? H plus 4. And you take the limit as H approaches 0. So guys, just so you know, because I don't know if anybody has seen a limit before, this is supposed to be like a smaller H approaches 0 right under your limit. Okay? That's how you write it. It's hard to do it on the smartboard like that. Okay? So, let's say it again. The slope of the tangent, that means the slope of that line that crosses through that one point. Okay? That line, that black line that crosses through the one point is equal to the limit as H approaches 0. So now you're making that difference 0 of the slope of your secant. Okay, and we're going to repeat this until it feels right. Okay, because this is basically the fundamental of calculus. Okay, so if you're finding the limit as H approaches 0, well, that means H is 0. H is 0. And so we know that the limit as H approaches 0 of H plus 4 is equal to 4. So what's the slope of our tangent? 4. So the slope of not that red line, that's the secant, but the slope of the tangent that would go through this. This is very hard to draw, but I'm going to try. There you go. So the slope of your tangent, which means it only crosses through that one point. So the slope of that tangent is 4. Okay? Are there any questions? So, in general, the slope of the tangent at an arbitrary point, that just means at any point, okay, is equal to the limit of the slope of the secant PQ as H approaches 0. So that's how we define the slope of the tangent. So there's my secant, it's green. My tangent is blue. You see how it's only hitting one point on my curve. So the slope of a tangent at any point P is your slope, right? Because that's what we're finding, slope, right? Slope is equal to limit as H approaches 0 of the slope of your secant, which is just delta y over delta x. Now, let's talk about this. Your function is f at x. Now, we have a coordinate, A. That's my x coordinate. My y coordinate is therefore f at A. You sub in A to get your y coordinate. You have A, comma, f at A. Now, my second point we said is A plus h. It's got a difference of h. Well, now my y coordinate is f at A plus h. And all I'm doing here now is y2 minus y1 over x2 minus x1. That's where this formula comes from. But we notice that all the time, because we're just taking a difference in our x values of h, that the denominator is always going to equal 8. And so this is the formula for finding the slope of a tangent. Does everyone see why this formula makes sense? Good. You're taking the slope of your secant, y2 minus y1 over x2 minus x1, and then taking the limit of h equals to 0. These are my 2 points. 1 point, 2 points. So f at A plus h minus f of A, that's my y2 minus my y1, and then a plus h minus h, that's my x2 minus x. This is known as the difference quotient and is fundamental to calculus. So basically, there's no calculus without this. This is where it all begins. Okay? And you're going to notice that calculus is all about slopes. Right? We're constantly finding slopes. Are there any questions so far? Okay. So, find the slope of the tangent to this curve. So what kind of a curve is this? Like an triangle? Yeah, it's a parabola. You know that because the degree is 2. The highest exponent is 2. So this is a parabola. So we want to know the slope of the tangent at the point -1/8. Okay? So we have this curve. You have a line passing through only this one point. So what do I do? What do I do? Well, first of all, if I have the point -1/8, what's my second point? -1 plus h, that's my x value. Yes, you guys agree? Good. And then my y value is going to be f at -1 plus h. We just sub it in, right? You always sub in x to get y. Sub in x to get y. These are now my 2 points. So, to find the slope, we know we have to take the limit as h approaches 0. Of just the slope of my secant. So again, it's the y2 minus y1. So it's f at negative, here, let me write the formula first, and then we get it. F at a plus h minus f of a all over h, which we now know is just f at -1 plus h, that's my y2, minus f at -1, which we know is 8, all over h. We know that the denominator is always going to simplify to h because that's the difference between our x values. Okay, so f at -1 plus h. So that means I have to do what? What do I need to do to find f at -1 plus h? What do I need to do? Oh, come on, I know somebody knows. Yeah, sub it into your equation. They're giving us an x value for your function f at x. Well, isn't y the same thing as f at x? It is. Right? One's in xy notation and one's in function notation. So we're going to sub it. So -1 plus h is going to get subbed into x squared minus 3x plus 4. That's what my y2 would equal. And then minus f at negative 1. Well, I know f at negative 1. They've already given it to me. It's 8. Okay, everyone expand this. Go ahead and expand this. Can you wait? Okay, go. Just sign up. Make sure you sign up. Sanitize your hands. Okay, so expanding here, I have negative 1 plus h times negative 1 plus h. So negative 1 times negative 1 is 1, and then I have minus h, which is minus 2h, h times h squared. There's my fourth. Now I have negative 3 times negative 1, which is positive 3, minus 3h plus 4 minus 8. There's my expansion. Check to make sure you got the same thing. Who can tell me what this cleans up to be? Collect your terms. What does this come out to be? What did I do? What did you get? Yeah, excellent. So it's h squared minus 5h over h. But we're going to factor out that h and cancel it. Yes? And you're left with this h minus 5. Now, we want to take the limit as h approaches 0. Well, if h is approaching 0, we can say that h is equal to 0. Notice, guys, I write my limit until I sub into it. As soon as I sub into it, I take it away. So now 0 minus 5 is equal to negative 5. That is the slope of the tangent that passes through the point negative 1.
If we don't write the 0, will we lose marks for an assessment?
Because for subbing in, yeah, you should show it.
Okay.
Especially now that you're just learning. So, the slope of the tangent at negative 1/8 is negative 5. Are there any questions? Yeah.
Do we have to rate the limit h is going towards like 0? Do we have to write that like every single time?
You must.
Like, through the steps?
Yeah, every single time until you sub in, you will lose marks for that. You have to.
All right.
Yeah, it's actually part of your calculations. It has to be there. Okay?
Yeah, it sounds good. Thank you.
Yeah, no problem.
Okay. So Vincent, can you like say like a variable feedback?
Well, we don't do that. We leave it. Okay? Okay, example 3. Find the slope of the tangent to the curve y equals 1 over x when x is equal to 2. So What do I do? Who can tell me what to write? I want somebody to tell me exactly what to write. I want the slope of the tangent. So slope of the tangent means I need the slope of the secant, and then I need to take the limit as h equals to 0, right? So y2 minus y1. Well, you know, it's a plus h minus f at a. There's my y2 minus y1, and we know that this will always clean up to 0. Okay, so here, what's my a value? I have an a value. They gave it to me. They're telling me x is equal to 2. What do I do next? What do I do next?
We sub into the equation.
Beautiful. We're going to sub into the equation y equals 1 over x. So f of x equals 1 over x. So I'm going to have 1 over whatever x is. Well, x is 2 plus 2. Minus. Now we're going to plug in 2. So it's going to be 1 over 2. All over 2. What do I need to do in order to clean up that numerator?
Common denominator.
Got it. Common denominator. And what is my common denominator there? What's my common denominator there?
2 times h.
Excellent. So whenever you have a binomial, okay, or more than one binomial, then we know that to find the common denominator, we bring the two together. We multiply. Okay? It's the same idea if you have two denominators where one is 5 and one is 8. To find a common denominator, we multiply the two together. 5 times 8. We're doing the same thing here. Okay? So my common denominator is going to be 2 times 2 plus h. This is just the numerator I'm dealing with right now. Okay, so for this first fraction, to go from having a denominator of 2 plus h to 2, it means that I multiplied the whole thing by what? What did I multiply this denominator by? To get this denominator.
2.
Yep, multiplied by 2. So whatever you do to the bottom, you got to do to the top, right? We're creating equivalent fractions. So I have 2. Minus my second fraction. What did I multiply this by to get 2 times 2 plus h?
2 plus h.
Yes, it did. Whatever you do to the bottom, you do to the top. Notice I put brackets around. If I didn't put brackets around, I'd get the wrong answer. We're subtracting a binomial. You have to have brackets there. Okay, now this whole thing, this is just my numerator. This whole thing is divided by 8. Okay, so now what does my numerator clean up to be? So here I'm going to have 2 minus h all over. Should I expand? I'll answer that for you and say yes. Okay, so I'm left with negative h all over 4 plus 2h. And now I'm dividing by h. Well, h is the same thing as h over 1. So it's like multiplying by 1 over h. And now you should notice that the h is canceled. And so now I'm left with negative 1 over 4 plus 3. And now I've got to take my limit. So what do I do? I want to take that limit. So what do I do? What do I do?
You sub in h is equal to 0.
Got it, thank you. And I get negative one. Negative one. Therefore, the slope of the tangent is, at x equals 2 is negative 1 over.
Miss, do you have to write the formula each time for
You
the
do.
limit?
Yeah, you do.
Like the f at a plus h minus f at a over
Yeah.
h? Okay.
Yeah. Okay, may I go to the next example? Okay, so doing more of the same, now just with a different function. Now we're talking about a root function. So find the slope of the tangent to the curve y equals radical x minus 2 when x is equal to 6. So now what? What should I do?
You sub in the x.
Yeah, sub in the x, sure. So let's start by writing our formula. Slope of the tangent is equal to the limit as h equals to 0 of y2 minus y1 all over x2 minus x1. Okay, so in this case now my a value is 6. So maybe what I'm going to say is you don't have to write this one, but make sure you at least write this one. How about that? Okay? Fair enough? So this top one, you don't have to give me as long as you give me this one. One of the two. Okay? The second of the two. Okay, so now, what do I do next?
Sub it in.
Yeah, sorry, I'm missing an F there. So F at 6 plus h. F at 6 plus 8. So that means we're subbing in 6 plus 8 in for x. That's what I subbed in. And now I'm going to sub in 6. And all of this is divided by 8. So cleaning this up, it's 6 minus 2, which is 4. So I've got radical 4 plus h minus the square root of 4. I'll show it. Put it equal to. And now, what happens if I just take my limit? Because that's what we would do now, right? We would say, oh, let's just take our limit. So if I take my limit, what happens? Yeah, it's undefined. That's not true. It's not undefined. If it's undefined, then it is a vertical line, doesn't it? It's not. So what do we need to do? What do you think the problem is there? What do you think the problem is? The problem is I have h in the denominator. We need to get rid of that h in the denominator. We need to find a way for these h's to simplify. So think back, I think back to grade 11. What can I do here to manipulate this expression? Does anyone at home know? What can I do here to manipulate this expression? Yes, we're going to rationalize. In this case, we're not rationalizing the denominator. You guys are used to rationalizing the denominator. This case, we're rationalizing the numerator. What does that mean? It means I want to get rid of these square roots. That's what it means. I want to now make it rational. I want to make it a rational number. Okay? Okay, so how do I do that? Who remembers? We talked about it yesterday a little bit. I used the word. What was the word that I taught you guys yesterday? You multiply by the, what was that word? Does anyone remember? Anyone at home?
Conjugate.
Yeah, by the conjugate. We want the conjugate. The conjugate means you keep your terms exactly the same and you only change the sign in the middle. Now with expressions, you can't just multiply something in, you're changing the expression. But I can multiply by 1, that's not changing the expression. So whatever I multiply the bottom by, I also multiply, whatever I'm multiplying the top by, I must also multiply the bottom. Okay, so now this is going to get fun. If I multiply root 7 and root 7, what does it equal? 7. If I multiply root x times root x, what does it equal? X. So if I multiply root 4 plus 8 times root 4 plus 8, what does it equal? 4 plus 8. Very good. That's why we did this. Now, because I'm multiplying by conjugate, you already know that the middle terms will disappear, so we don't have to bother with that. That's why we did this. My middle terms will disappear, so I don't bother. I just jump now to root 4 times root 4. Well, root 4 times root 4 will be 4. And it's a negative. A negative times a positive is negative. In my denominator, do I want to expand? What do you guys think? Do you guys think I want to expand? Should I expand that each? What do you think? Good idea or bad idea? So let's think of our goal. Why are we doing this? The whole reason we're doing this is why. Why did I do this? Why am I going to all this trouble? The reason I'm going to all this trouble is because I got 0 in the denominator. I know that I need to cancel h. My goal is to cancel that h. I don't want to expand it. I need it separated. I want to get rid of it. So I'm not going to bother expanding it. Now I clean up the numerator. And I have 4 take away 4, which is 0, and I'm left with just h. How convenient. Now my h is canceled. Can I take my limit now? Yeah. So do you see how we got an answer of undefined, but it was false? We weren't supposed to simplify it. We needed to simplify it more so that we could, in fact, take our limit. And so now I sub in my 0, and I can take away the limit sign. Well, root 4 is what? What's the square root of 4? Yeah, it's 2. Which I could have taken a lot earlier, right? So therefore, the slope of the tangent at x equals 6, or when x equals 6, doesn't matter. 1 over.
Do we have to write limit h approaches 0 every single time?
Yep, every single time.
Okay.
Yeah, you must, every single time. Okay, so this is your homework for this section. I'm gonna give you guys maybe 10 minutes just to do a couple of the questions, and then we're gonna start with the next section. Yep, I'll give you your textbook. Okay, so you guys at home, just start working on the homework. Very shortly, we're gonna do the next lesson, but I want you to just do a couple of these before we start the next lesson, okay? Of course. Yeah. You have to, but I don't think they're allowed to use the fountain. I think you have to fill up your, right? You have to go to like one of the water bottle filling stations. I know I forgot my water today. Okay. Oh, did anyone come to pick up your textbook? Regine, did you come pick up your textbook?
No.
Regine, come and get your textbook.
Can't I just use the Nelson one you post online?
I can't leave that online the whole semester. That's just temporary.
What if I download it?
I don't know. I can't speak to that.
I'll just download it today.
I don't need to know that. Okay. Then who else? Blanca, did you come pick up your textbook?
Could I do it tomorrow?
Yeah, for sure you can.
Okay, thank you.
But tomorrow's the last day, so make sure you come.
Okay.
Yeah. Lan, what about you? Did you pick up your textbook?
That's because I'm not in Toronto now, so let me just use the online one.
Okay. All right, so you didn't get it. Okay. Joseph, what about you?
I'm planning on going tomorrow.
Okay. And what about Michael? Michael? I think Michael, I have to check the chat. No, Michael? Michael's not here? All right, so those are the information. Let's do it. Okay.
Nice.
He left the room.
All right. How are you guys doing? Okay? Are there any questions? Okay, so I'm looking at the schedule, guys. Today we're doing 1, 2, and 3. Thursday is 1, 4, 1, 5. Friday is 1.6 and review. Okay, so Friday is the last day of the lesson, of the chapter. So that means you're a test. So I'm gonna ask you this. Would you rather I test you Monday the 23rd, and then we go ahead on the Tuesday, or potentially after the test on that day if there's time? Or would you rather that I start the next chapter on Monday and give you guys till Tuesday to study for the test? It's up to you guys. Should I ask you closer to and see where you guys are at? So just, it's true, you're right. Okay, so what we're gonna do, just keep in your head that there's gonna be a test either Monday or Tuesday of next week on chapter 1. Okay, Monday or Tuesday next week, you're gonna have a chapter 1 test. Did everyone at home get that? And what I will do as well is put it in the calendar in the class.
Miss,
Yeah.
could you make a poll?
Oh, yeah, I could. That's new, eh? We're allowed, we can do that now. Yeah, for sure I can. I'll do it, I'll make a poll maybe tomorrow or the next day just to give people a chance to see where they're at.
Miss,
Yeah.
did you call me?
Is this Michael?
Yeah.
Hi, Michael. I just wanted to know if you got your textbook. Did you pick up your textbook or not yet?
Oh yeah, I've got it yesterday afternoon.
Oh, you did? Perfect. Excellent.
Yeah.
Can you confirm the number with me? Give me 1 second.
Oh, okay. So can I type it?
you want to confirm it tomorrow? Do you have it with you? Oh, you're going to go get it with you?
I think he said he's gonna type it for you.
Oh, thank you. Thank you. Oh, yeah, he did. Yeah, perfect. Thank you, Michael. That's great. And was that Selma that was talking to you?
Yes, it was Selma.
Selma, you sound so much like one of my past students.
Oh.
Oh my gosh, a lot. Okay, are you guys ready to start 1.3? Let's do it. Okay, so what you guys should notice is, so this is the beginning of my lesson for 1.3. So see how it starts with homework takeoff? So these are all questions that have been asked me previously. So use them as a resource to help you out. You also have that Prep Anywhere app. You'll see that there's quite a few questions here. Okay. Now this is a warm up. Usually we do this over 2 days, right? Not in 1 day. So I'm going to save this warm up for tomorrow, after you guys have had a chance to do more homework, and then we'll do this one together, okay? Or you guys will do it and we'll take it up. So that's going to be tomorrow morning. So let's leave that for now. And we're going to start here, and I have a handout for those of you in class. I think you guys already have it, yes? There we go. You guys having fun yet? Having fun yet? Yes, no, no, have fun? Big jump from grade 9, eh? Okay, so rates of change. So as I've already told you today, a rate of change is the same thing as a slope. But what's the difference? What's the difference? Rate of change, yes. Yeah, we include the units. Okay, that's the difference between rate of change and slope. With slope, it can be just a number. But with rate of change, we have units. Okay, so when we talk about velocity, velocity is the rate of change of distance with respect to time. Okay, that's what velocity is. So it's the change in v over the change in t. Makes sense? Your distance is your dependent variable, time is your independent variable. Hence, y over x. Yes, the change in y over the change in x. Good, that's velocity. In general, when calculating average rate of change, AROC, and instantaneous rate of change, so average versus instantaneous. So before we even get into this, average rate of change versus instantaneous rate of change. How is this going to relate to what I just taught you in 1.2? What do you think? Average versus instantaneous. Think of what those words mean. Yes. Yep. Average is a secant. You're finding the average rate of change between 2 points. Secant. Instantaneous is at it's a tangent. It's at 1 point. Okay. Good. So average rate of change is just the slope of your secant. That's all it is. It's just slope. And you guys did that in MHF. For instantaneous rate of change, well, now you guys know limits. So it's just your limit. It's exactly what we were just doing. Finding the slope of the tangent is the same as finding instantaneous rate of change. Finding the slope of the secant is the exact same as average rate of change. Okay? So what's the major difference here? One has a limit and one doesn't. Otherwise, everything else is the same. You guys see that? Good. A pebble is dropped from a cliff with a height of 80 meters. After t seconds, it is s meters from the ground, and its height can be modeled by the equation s at t is equal to 80 minus 5t squared. Okay? So the distance from the ground is equal to 80 minus 5t squared, where t is time. Find the average velocity between 1 and 3 seconds. Average velocity. Do I need a limit here? No, it's the slope of your secant. That's all it is. Slope of your secant. So how do I find the slope of the secant? Oh, everyone should be yelling at me. This is grade 9. Everyone should be yelling at me. What do?
Delta y over delta x.
That's it. And in this case, it's not y and x, it's s and t.
T.
So I sub in 3. There's my S of 3. And then I sub in 1. So 80 minus 45. 35. And then there I've got 80 minus 5. So 75. Minus 75. So I have, if average rate of change is negative 20, If I leave it like this, will I get full marks? No, you need your units. It's rate of change. So for those of you that have taken physics, I know that some of you will write it like this, which is totally fine. Showing the direction, right, into the following. That's okay, I will accept both. Now, it makes sense that this slope is negative, doesn't it? Why does it make sense that this rate of change is negative? What's happening to this pebble? Yes.
Height above the ground is decreasing.
Good, exactly. The height above the ground is decreasing. So it makes sense that the rate of change is negative. Good. Now, what is the velocity at 3 seconds? What is the velocity at 3 seconds? What's this one? Yeah, this is instantaneous. Now we want to know at a specific time, instantaneous rate of change. So now, I just take the limit. And now my x value, if you will, or my t value, is 3. And now we just have to sub into our function, which was 80 minus 5t squared. So 80 minus 5 times whatever t is, well, t is 3 plus h squared. And then f at 3. We've already found f at 3. What was f at 3? We found it in the first example. What was f at 3? 35. Okay, we need to expand here. 9 plus 6h plus h squared. Now we need to clean it up. Notice I'm writing my limit every single time. Expanding my bracket there. And now we just clean it up. So I have negative 5h squared minus 30h. Am I left with any constant? 80 minus 45 minus 35. What do you guys think? Can I hit my limit now? No. What do I need to do? Yeah. Factor and cancel. So if I factor out an h and cancel it, I'll be lucky. You guys need me to show that stuff, or is everyone okay? Good. And now I just sub in 0. Remember, this is rate of change. We use statements with our units. Negative 30 meters. Are you guys good so far? Really, we've learned nothing new, right? Exactly what we did in last lesson. We're just now telling you that slope of the secant is average rate of change, and slope of the tangent is instantaneous rate of change. Don't forget to consider this. That's the only difference. Good, so really nothing new here, just different way of asking a question. Okay, last example. Suppose that a foreign language student has learned n at t equals 64t minus t cubed vocabulary terms after t hours of uninterrupted study. So we're studying, and this is the number of words that they're learning. Okay, n at t is the number of words that they're learning over time. How many terms have been learned at time t equals 3 hours? What should I do? You sure? Look at what the question's asking. Careful. It says, how many terms have been learned? Not what's the rate that they're being learned at this time. It's saying, how many terms have been learned? So now, choose your answer. What should I do? Are they asking for a rate of change at all? Here's the question. How many terms have been learned at? Yeah. Yeah. I know it's tricky, right? But it's simple, but it's tricky. Because you guys know, when you see one time, you think right away, oh, it's the rate of change. No. In this case, they're just asking for n at 3. That's it. Times 3. Help me out, guys. Let's make sure everyone's awake. 192. 3 cubed. 3 times 3 times 3. Yep. 192 minus 27. Good. 160. Therefore, 165 terms. Okay, now look at this question. What is the rate that terms are learned? So now it's different. Now they're asking for the rate. So now we need to score. So what is the rate that terms are learned between t equals 1, t equals 2? Average or instantaneous? It's average. Between 2 times. So do I need to take a limit? No. So n at 2. So my function was 64. 64t minus t cubed. And then minus n at 1. So n at 1, guys, if I sub in 1, very easy to see. It's just 64. And it's all over. 64 times 2 minus 8 minus 64 is...
Miss, it would be 63.
Oh, sorry, excuse me. I apologize. I meant to write 63. Thank you. All right, 64 minus 1. And so now, what do you get? How many terms? Go ahead. 57. Okay? Terms per hour. Don't forget your unit. What is the rate in terms per hour at which the student is learning at t equals 3? So now 3 hours have passed, and they want to know, at the 3 hour mark, how many words is the student learning at the 3 hour mark? So what do I do now? Guys, what do I do now? Anyone at home? What do I do now?
Limit.
Hi, Rob. Exactly. Hi, Rob. Beautiful. So that means I need a limit. So now we're subbing 3 plus h into you already know NFP. Okay, when you're expanding this, yes, you can go ahead and just expand, no problem. Like for 3 plus h, 3 plus h, and 3 plus h plus 3 plus h. Or you can use Pascal's triangle. You guys remember Pascal's triangle from grade 11? Can't remember if you used it in the HS. You guys remember? No? Everyone's looking at me like, what is talking about? Pascal's triangle. It tells us the coefficients. Yeah, do you guys remember how to use it? Binomial theorem expansion? Yes, no, maybe? Yes or no? No. Okay, so ready? So if you have 3 plus h2, yes? So 3 plus h2, 3 is my first term, h is my second term. You guys remember you do 3 to the exponent 3 times h to the exponent 0 plus 3 to the exponent 2 times h to the exponent 1. 1 goes down with 3, 1 goes up with 3. They always have to add up to 3. Yes? Is it coming back? Oh. Review Pascal's theorem. It comes in handy when you're doing big expansions. No?
Will we have to write IROC on a test?
Yeah. You do. So when you're expanding 3 plus h to the exponent 3, you know that you're going to have 4 terms. Yes? So this is the row that I'm using from Pascal's triangle, 1, 3, 3, 1. So that means my first coefficient is going to be 1, and it's 1 times 3 cubed. And what's 1 times 3 cubed? 27. Now, for the next one, your coefficient is 3. Right? Hold it here. 3. And then you're multiplying now by 3 squared, h to the exponent 1. So it's 27h. Oh, I'm sorry. I'm not expanding that yet. For your next term, the coefficient again is 3. So now it's 3 to the exponent 1 and h squared. So it's 9h squared. They're always positive because both of my terms are positive, yeah? And then for the last one, it's going to be a coefficient of 1, 3 to the exponent 0, which is just 1, and h cubed. That's how you use binomial theorem and Pascal's triangle together. Cool? Yeah. It's not hard when you know binomial theorem, right? Okay, so guys, cleaning this up. You guys tell me, what does this clean up to be? I'll write it there so you guys can look it up. Those of you that don't remember. Regine, are you there? Yeah, Regine. You remember when I taught you this? Make sure you answer correctly here. You're supposed to say, of course I do, miss.
Of course, miss.
There you
Never
go.
forget.
Of course I do, miss. Because believe it or not, I did teach it to you, whether you remember or not.
Yeah.
Okay, what does this clean up to be? Regine, what does this clean up to be? Tell me what you got.
I'm not gonna lie, miss. I got really hungry, so I started making French toast. Like,
From scratch?
yeah.
Okay, listen, I'm very proud of you. That's fantastic. But what are you doing in the middle of my lesson?
I'm sorry. Like, I was so hungry. I stopped paying attention for like the past 5 minutes.
Okay, ready? Hands up if you believe that. Exactly. Hey! Okay, we had one hand up. Clearly, some people are naive. Okay. I'm gonna start picking on people at home just to make sure you guys are with me. That's what I'm gonna do. Yes, I'm gonna do that. Because I feel like I'm teaching only the 4 people here.
Well, at least I'm doing my homework this semester.
Can you hear the giggles? I'm getting a lot of giggles in here, Radine. Can you prove this?
I don't know why they're giggling.
Yeah, I know why they're giggling. I've taught you before. But you know what? I want you to prove us all wrong. Got it, Radine?
Okay.
I'm counting on you to prove me wrong.
All right.
Okay, good. Okay, who else can help me?
Miss, do you want the simplest form?
Yes, please.
I got till the part that I went was like I got 37h minus 9h2 minus h3 over h.
Okay, so 37h minus 9h squared minus h cubed all over h. Beautiful, thank you. And now, am I ready to sub in 0? Sorry? Yeah, you have to, right? We have to at this point now. I like to just ask questions like this, even though I know you guys know the answer, but just so you remember, if I sub in 0 here, it's going to tell me that it's undefined, but it's not. We just haven't fully simplified. So yes, we want to factor out that h, and Selma, I know you did it. I know that you just gave it to me like this, which I appreciate that you did. So now we factor out the h and we simplify it, and you have 37 minus 9h minus h squared, I apologize, and now we sub in 0, so I can take away my limit. And you're left with just 37 terms per hour. So what's happened over time here? What's happening? You guys see a trend? What's happening?
Decrease rate of change.
Yeah, so what's happening to this student? Well, as time goes on, you get tired. So at the beginning, you're learning all these terms, and as the time goes on, we notice that the students are learning fewer and fewer terms. Yes, they're getting tired, right? Good. Excellent. Are there any questions? So let's sum it all up. I want to find the slope of the secant. What do I do? I want to find the slope of the secant. What do I do? So that means the slope that goes through of a line that's going through 2 points on a curve. Slope of the secant. What do I do? Oh, come on, everybody should be yelling at me. Sorry? Yeah, good. So, yeah, you're going to use y2 minus y1 over x2 minus x2 minus x1. If you want to find the slope of the tangent, now I want to find the slope of a tangent. Not rate of change, just the slope of a tangent. What do I do? Just put limit as h equals to 0 in front of it. Yes, it's the slope of the secant, but you're just putting the limit as h equals to 0. And then I want to find average rate of change. Well, the same thing as slope of the secant, just in your answer, include units. I want to find instantaneous rate of change. Same as slope of the tangent, just make sure your answer has units. Right? Good. So slope of a tangent and instantaneous involve limits. Average rate of change and slope of the secant are just your regular slope. That's it. That is your homework. No, guys, this is sorry. We do not have a quiz. No. Does it say quiz? No, I was going to say, I think we never have quizzes. To be honest, the calculus course, we never have quizzes. What we have are, every chapter has a PA, and it is always one question or 2 questions from your homework. And what the kids used to do was, they were allowed to use that page. If they were allowed to use the question from their homework, if they had it done, they could use that question only, and they could literally just copy it. It was an incentive for people to do the homework. So, and it was only worth 5% more. Now this, but there were never quizzes, just so you guys know. This year it's a little bit different. You guys are pretty much open notebook, so we're not going to do that. Okay? Okay, looking ahead. I want to I don't know if this link exists anymore. It used to. I have it saved so I can show it to you. I don't know if you're going to be able to find it, but it's called Calculus Folk. These are awesome videos to teach you limits. And I am going to show them to you tomorrow. But if you get a chance, if you do happen to find them, watch them. I personally love the guy's voice. I think some people find him very boring. I don't. I think it's awesome. But anyways, I am going to play them for you tomorrow. But if you have a chance, go and check them out. Calculus Folk.
Miss,
Yeah.
where do you want us to look for the video?
Just Google it. I don't know if it's still going to be available. Like I've had this for years. I do have them saved, so I'll show them to you tomorrow. But just Google Calculus Folk, and you're looking up the limits videos, chapter 1 videos.
Right, because it's not on YouTube, so.
No, it wasn't a YouTube video. It wasn't. I don't know. It might have been. I don't know. I want to say Flash, but I don't know.
Yeah, it sounds interesting, though. I want to find it.
Yeah, don't worry. If you don't find it, I will show it to you tomorrow. But they're really, it's kind of similar to the Khan Academy videos, but it's just a really, really easy, simple, nice way to talk about limits. So I will show you tomorrow.
Miss,
Yeah.
you made me underachieve my breakfast.
What happened? What did you say? Why? How did I make you underachieve?
I don't know, the way you said French toast from scratch made me worry, and I panicked, so I didn't make it. I rubbed some feta cheese on it, on my toast. I just thought that was relevant.
Okay, so hold on. I'm confused. Did you dip the bread in it?
Well, I wanted to make French toast. I was looking up recipes, and the way you said it made me think like maybe I wasn't up for it.
Oh my God. Oh gosh, Rajeev. I just assumed that you had done it before.
No, I was looking for recipes.
No, do it. You should have done it. So now instead, you just threw some feta cheese on your toast.
Yeah,
So my
it was
husband.
disgusting.
No, it's not disgusting. So oh my gosh. So my husband, his background is Macedonian, so they eat a lot of feta cheese. They actually eat French toast, no syrup. You don't put syrup on it, but they'll eat their French toast that's dipped in egg and fried on the frying pan. They'll eat it with feta cheese.